Welcome to Get Your FRQ On. This question is from 2025. It's question 4, and it is not calculator active. In the question stem, we have a continuous function f defined on the closed interval from -6 to 12. The graph of f consists of two semicircles and one line segment. In addition to this, we have a function g defined as the integral from 6 to x of f of t dt. In part A of this question, we are asked to find g prime of 8 and to give a reason for our answer. G of x equals the integral from 6 to x of f of t dt implies that g prime of 8 is simply f of 8, which is just 1. In part B of this question, we are asked to find all values of x in the open interval from -6 to 12, at which the function g has a point of inflection, and to provide a reason for our answer. The graph of g will have a point of inflection when g double prime of x equals 0 and also changes sign, or if g double prime of x fails to exist but also changes sign. G of x equals the integral from 6 to x of f of t dt implies that g prime of x is f of x, which implies that g double prime of x is f prime of x. F prime of x equals 0 implies that x is either -3 or +3. And we note that f prime of x fails to exist at x equals 6 and does change sign at x equals 6. From this, we can conclude that the graph of g will have points of inflection at x equals -3, +3, and +6. In part C of this question, we are asked to find g of 12 and g of 0 and to label our answers. G of 12 is the integral from 6 to 12 of f of x dx, and that just turns out to be 9. G of 0 would be the integral from 6 to 0 of f of x dx, which is the opposite of the integral from 0 to 6 of f of x dx, and that turns out to be -9 pi halves. In part D of this question, we are asked to find the x value at which g attains its absolute minimum value on the closed interval from -6 to 12 and to justify our conclusion. Since f is continuous on the closed interval from -6 to 12, g is differentiable on the closed interval from -6 to 12, which implies that g is also continuous on the closed interval from -6 to 12. The function g can attain its absolute minimum value at either x equals -6, x equals +12, or some value of c between -6 and 12, such that g prime of c is equal to 0, or is undefined and changes from negative to positive. G prime is equal to f, and f of x is equal to 0, or fails to exist with a sign change from negative to positive only at x equals 0 and x equals 6. So just evaluating at the candidates, g of -6 is the integral from 6 to -6 of f of x dx, that's 0. G of 12 is the integral from 6 to 12 of f of x dx, that's 9. G of 0 is -9 pi halves, as we've already determined, and g of 6 is also 0, based on properties of integrals. Therefore, the absolute minimum value of g is attained at x equals 0. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.